When we think of the name Titanic, we tend to think of the luxury, the elegant lounges, the palatial suites, that sprawling, magnificent staircase, all the modern conveniences like warm electric lighting and heaters. But powering all of it was a steam power plant that was immensely large and impressively efficient. Titanic's engines were stories tall and they sat deep in the ship's bowels. The engineers down there had to essentially live and work in and around their machinery. The triple expansion steam engines that drove Titanic into destiny today sit silent and exposed. James Cameron said they're like a pair of twin sphinxes that guard the wreck. But once upon a time, these amazing machines were alive with noise and movement. Since the rediscovery of Titanic's wreck, one company, RMS Titanic Inc, has maintained the title of salvor in possession, allowing them to visit the site and retrieve artifacts for preservation and, most importantly of all, display. Getting to visit their headquarters, where the artifacts are kept and lovingly maintained, has long been a dream of mine, and fortunately, last year I got my chance and met exactly the person who could tell us all about them.
Hi, I'm Tomasina Ray, President of RMS Titanic Inc. and Director of Collections.
This is the second episode of a series where we learn about Titanic through the objects that were actually on board, the machinery, the human touches, and everything that made Titanic into a working ship. Today, Tomasina brings us a very special and rarely seen piece of Titanic's engines. But first, this curious-looking instrument that once helped navigate the massive ship through the open ocean.
What are we looking at?
So this is the logometer that Titanic was using the night it sank. It was attached to one of the rails, and it would have been telling them how far they had traveled each day. Starting at noon, they would reset it and be able to take a reading so they knew if they were making time.
The patent log was crucial for navigation. Aside from the crew taking celestial readings from the stars to figure out the ship's progress, the log could tell exactly how far Titanic had gone instead. It's a little-known fact that the ship was trailing a small brass device through the water behind her, attached to a long line about 100 meters or 328 feet, that led to the meter seen here, attached at the stern. The fins on the log itself kept it spinning through the water as Titanic went along. The spinning of the log and the rope that was attached to it turned the meter's mechanism, keeping track of the distance that was travelled. It was a simple, mechanical system that worked remarkably well. Titanic's log meter has survived incredibly well preserved.
I mean, this is a really important part of the Titanic story because it is tracing how far she is traveling through the water.
Yeah, and it still shows, obviously, the frozen time or the frozen distance it had traveled since being the last day, which in this case is 268 nautical miles. And, we mentioned that it still pivots on all these points. And I don't think they use these anymore on ships.
No, they've got some electronic system that keeps track of everything. Of course, back then everything being manual. You had to dangle essentially a fishing line with a weight over the back of the ship and use this to the painted log to keep track of how far you were going.
This was obviously critical for navigation on the bridge, but it served a double purpose and became a source of entertainment for passengers. The daily distance travelled would be posted publicly for the passengers the next day, and it became a popular focus of betting. This was tradition on the big passenger steamships. In fact, the daily bet and its pool became so raucous that on some ships an officiator kept order with a wooden gavel. On Mauritania, one of the smoking room tables, which was obviously the designated table for officiating the procedure, featured deep marks worn into the wood from decades of abuse by the gavel, as the officiator auctioned off the more popular numbers. The log meter is a priceless reminder of the modernity of Titanic, the keen interest passengers took in her pace as she sped up across the Atlantic and the engines were worked up. On her first day out of Queenstown, Titanic managed 464 miles, then 519 on the second, and 546 miles on the third.
This being a metal, it's bronze, and what we're most concerned about is the presence of chlorides or salts that would be residual from having been submerged under the ocean for decades. So the first thing that we'd want to do is have it desalinated, and that can be done either through water baths or using electrolysis. This probably went through electrolysis just because it is such a heavy metal object and such an important one. They would have wanted to do that as efficiently as possible. But one of the things that we have to be careful of is keeping the metal artifacts in a lower humidity so that water which would combine with salt and chlorides, doesn't cause further corrosion. So that's one of the things that we check for all the time with the artifacts and try to monitor just to make sure there's nothing active or changing about them. And the fact that this still moves is actually important to note because those pivot points mean that there's some amount of space in there, which is where corrosion can happen the most, where we can't actually see it or get to it. So that is important for us to realize and to recognize and to watch in this case in particular, because he does have so many points that move. His little handle back here, the pivot point here, and actually he pivots on this axis underneath as well.
Does that one still work?
Yeah, I think he can still turn just a little bit to the sides. Yeah, so just they still have movement and life, and some things are frozen. Some of the pivot points on some of the other artifacts do not move. We don't want to ever force anything, but this one is great because it still does. And I love that the green patina is still there, and you can see how the foot is bent from being wrenched off the ship during the sinking. It tells so much of the story.
Yeah, the violence of the sinking right at the end there.
The fact that this artifact was found at all, let alone in such an intact state, is something of a miracle. Right at the end, with Titanic's stern pointed towards the heavens, the logmeter was lifted high up, with the fantail hundreds of feet into the air. Presumably, the log itself was dangling, still attached to its rope from the stern. All around it must have been chaos, the cries of terrified passengers just feet away. And then came the final plunge. The stern was pulled under without having fully flooded. Collapsing air pockets and the sheer violence of the hydrodynamic currents tore whole chunks from the ship. The huge electric cranes were prized away, and the entire poop deck was ripped up and peeled over on itself. The logmeter was ripped from its mount and spat into the debris field, only to be found 82 years later, still showing the final distance reading, around 260 miles since the log had been reset at noon on the day of the collision.
So everything we recover is from the debris field. It's lying somewhere on the sea floor, and this was our third expedition in '94, so they were still kind of at the point where they knew the main areas of the debris field, and they would go through and just look for what seemed like an important artifact to recover. So we have this one, and we actually have the spare logometer as well.
Really?
Mm-hmm.
Is this one in better condition?
This one, the other one is frozen, so the other one doesn't pivot on any of its points, and everything is set to 0, which I think it's interesting that ships carried so many spare parts. I like that it tells the whole story. And that's what I love about the artifacts in general, but this talks about the navigation capabilities in 1912 through what it actually was. It talks about the trauma of the sinking through this foot and through the patina, the decades under the ocean. But this is something that is important to people who are nautical history enthusiasts, people who are Titanic enthusiasts, and I think that's why this piece is so important.
Of course, measuring Titanic's daily run was critical, but the machinery used to actually drive her through the water was the star of the mechanical show. Down beneath the logmeter on the stern were the 3 enormous bronze propellers that churned through the ocean, spun themselves by the ship's massive engines, whose scale is still, nearly 115 years later, simply mind-boggling.
So this is eccentric strap. This is one of the largest artifacts that we've recovered. This was recovered in 1993, and the submersible actually used rigging straps. One of the tools that it had with it was a metal pole with the straps attached to the end, kind of like a needle, and it was able to strap around this in strategic points to be able to hoist it to the surface and collect it that way. So this was a challenging collection, but by then they had kind of had time to see what was down there and decide what to collect and strategize how to collect big things like this.
The eccentric strap is part of a clever assembly called the Stephenson's valve gear. Mechanically, the thing is quite simple, but explaining it is surprisingly difficult. In essence, the system could control the direction of Titanic's engines through adjusting the cutoff of the steam intake, or in simpler terms, at what point in the engine's stroke the steam inlet valves close, which prevents steam from entering the cylinders. The The Stephenson system also ensured that for a required power output, the steam valve for each cylinder would only be admitting the exact amount of steam actually needed for a piston stroke. It meant that excess steam wouldn't be wasted. The eccentric strap itself was the outer ring of a two-part component, with the eccentric pin sitting in the middle connected offset to the crankshaft. Titanic's engine cylinders each had a pair of eccentrics, giving the ship 8 in total. This type of engine had been perfected over decades of use. The reciprocating steam engines of Titanic's day were probably the very pinnacle of the technology, but soon they would be replaced totally by steam turbines instead. Titanic did have a turbine. In fact, her engine setup was quite unusual for a ship of her day. Designers had seen that the Parsons steam turbine fitted to liners like Mauretania and Lusitania. They'd read the reports, and they had a good understanding of the engine's quirks, its benefits and pitfalls. Harland and Wolff and the White Star Line had decided on a hybrid system for Titanic, making use of the reliability and the efficiency of the triple expansion steam engine and the power of the turbine. Titanic's turbine made use of the waste steam that was being exhausted from the big main reciprocating engines in an arrangement that saw every tiny bit of energy being squeezed from the steam itself. Many ships have used triple expansion steam engines, but few have had units the size of Titanic's. These monsters stood about 40 feet or 12 meters tall, something around the height of a 4-story apartment block.
Seeing something of this scale, like what does this do to people that see it? It's just seeing a big piece of Titanic, right?
I mean, this is instantly recognizable when you come across it on the seafloor, and to see pieces of scale that you can recognize, you know there are multiple pieces, that it cut all the way through top to bottom of the ship, all the way through, clean through to that engine room that you mentioned, is just such a massive force to dislodge something this heavy and significant from Titanic.
The scale of this thing is truly something to behold. Bearing in mind, this component is a relatively small part of a much bigger machine. It was all made at Harland and Wolff in the engine shop, a simply enormous warehouse where the mechanical components of the big ships were built conveniently nearby to the vessel they would one day power. Harland and Wolff did outsource some specialty jobs, like forging massive castings and the creation of life-saving appliances like the lifeboat davits, but the engines were built from the ground up in-house. The entire assembly would be test-fitted in the warehouse and then taken apart for transport down the road to the fitting-out wharf. The engines were lifted up in pieces and assembled like some kind of giant Lego kit down in the ship's guts. It's incredibly impressive, and you have to remember that all of this, the insane degree of accuracy and quality, it was accomplished in a time without computers.
So what materials are we looking at here? Because there's different states of preservation present.
Yeah, so the major part of this is cast iron again. So you can see the pitting and the raw iron, which gives it this kind of wood grain look on some of these nuts that are holding the strap together. And then the inside would be a bronze surface that would allow the eccentric disc to stay and move. A little smoother surface, a little smoother ride. And so conservators, when they're dealing with something like this, would need to stabilize the surface, and that would mean removing any corrosion on it. And that's usually a mechanical process with something this big. So they actually use abrasives and kind of just fire it at this almost to get the surface down to a point that's stable. And then they coat it with a wax to seal it once it's cleaned and stabilized.
Because we were talking about osmosis and desalinization. So is there seriously just a tank big enough for this that you just put it in one piece, or is it doing section by section?
No, you're putting, this whole thing would go in one piece. There were a couple of pieces that are reconstructed here that had come off or not been completely stable, but those pieces are removed and the piece is stabilized and as one complete piece as possible. We never want to disassemble or break something just to have to put it back together again. So that this would have been done in one piece. And then the conservators also helped us build this mount for it, which is used to transport it around and also to put it on view. It never leaves this mount just for its stable. It's just so hard to handle, and we wouldn't want to have it in an unsafe situation. So it stays mounted to this. It has supports here that can be taken away when it's on exhibition underneath it, just stabilize it just a little bit if we were to transport it. But other than that, it lives on this mount and is stable for exhibit.
When Titanic broke apart at the surface, the engine room was right in the firing line. Throughout the night, the ship's engineers, led by Chief Joseph Bell, had fought valiantly with pumps to try to stem the flow of water and feed the boilers to try to keep steam up for the dynamos to power the lights. Titanic took a long time to sink, but then the end came very quickly. Reports seem to suggest that Bell had released his men right at the end. Fortunately, they had a direct escape route, climbing ladders up to the boat deck directly from the engine room, but still, none survived the ship's violent end. Titanic was torn apart near to her middle. The forward set of engine cylinders and their solid, 6-foot-tall case bed plates were ripped right off and sent into the abyss below. The eccentric strap that RMS Titanic Inc. retrieved was one of the spares. It was kept mounted to the inside of the hull in the engine room. Researchers suggest this because the strap itself isn't damaged, whereas it would have needed to be ripped off the eccentric pin and the crankshaft if it had actually been installed, something that would have been impossible without the whole thing breaking into pieces.
I think something like this, when we talk about the sinking of Titanic and what the people in the engine room and the boiler rooms did up until the last minute, that's such a heroic story. They had to keep the steam in the engines running so that there was power for the lights, so that there was power for the telegraph system to be able to reach the other ships, and so that passengers could reach the lifeboat safely. So the work that these pieces did was essential, and those workers who stayed till the end to ensure that the other passengers had a way and a chance. It's such a great story.
Yeah, it really is. It's moving. I mean, it's amazing that they did what they did.
Yeah, to stay in a ship where you don't know what's really happening for sure.
Yeah,
and continue to operate.
I like to think I'd be one of them, but I think I'd be one of the first ones up the ladder.
I would be so scared.
Yeah.
I think, there's a certain amount of maybe ignoring what's going on around you that you're like, I'm just going to keep going, because you can only see what's in front of you. But that's a very uncertain situation. I don't think we can imagine today with the amount of communication we have and the amount of information we have at any given time and the ability to communicate. So, yeah, that must have been terrifying.
When you see a piece of Titanic's engine, you're reminded of the fact these components had been machined to survive millions of revolutions and years of service. Olympic, Titanic's sister, used identical components that were built at the same time alongside Titanic's, and she served for the better part of 20 years, travelling countless miles. It was the kind of career Titanic should have had, but never got to enjoy. In fact, when Olympic was scrapped in the 1930s, her chief engineer was particularly sad because, according to him, her engines were running the best they ever had. Such was the quality of construction of the machinery at the time.
For anyone who isn't familiar with steam engines or how Titanic worked, this is a really good example of an artifact we can use to talk about those lesser known parts and mechanics of Titanic and how steam engines work and how this would have had to push a rod with the piston up and down to direct steam throughout the engine. So this is kind of a cool piece to do that with, because people just see it and they're like, what is that? And it kind of invites the question, and then you can explain to them a little bit more about Titanic.
I've seen smaller steamships like the Olympia in Philadelphia. She's built in 1895 and she's got very similar engines to Titanic, a lot smaller, maybe like third scale. And they have the eccentrics in place and the eccentric straps like this, and they're maybe like that big.
Yeah.
And looking at this, then it's impossible not to like extrapolate upward and think, okay, well, this is the size of the eccentric and the crankshaft, and then you're going up 3 stories. I mean, that is a monster of an engine.
And then this being out in the open and moving wildly around, just with workers probably walking somewhere near it.
Yeah.
Like this is a very big piece of equipment to be moving that fast and that constantly.
There are a few artifacts that give the scale of Titanic purely because I would assume the difficulties involved in bringing them up, but the holy trio has got to be this, the davit that you have, and the big piece.
This davit, big piece, and a little piece, and D-deck door are actually our largest artifacts and some of the most challenging that were recovered just because of their size.
Part of RMST's goal is to preserve Titanic artifacts so they can be displayed around the world and demonstrate different parts of the ship's story. Of course, for rivet counters like me, the steam engines and the equipment are extremely compelling, but so too are the intact plates and the dishes, still ornately patterned to this day, the silverware, and then the human items which make Titanic such a moving story. Next time, we'll look at more of the human items recovered from bags found littering the ocean floor. A diamond ring, whose owner remains mysteriously anonymous to this day, sheet music, still intact and very readable even though it's made of paper, and clothing that looks like it was made yesterday. Join us as we reveal more of Titanic's secrets and her stories through the items that were actually there, and we'll explore more of RMS Titanic Inc's incredible catalogue of items. Ladies and gentlemen, it's your friend Mike Brady from Oceanliner Designs. Thank you so much for watching this video. If you enjoyed it, please leave a comment below. And don't forget to subscribe to the channel because we get new videos out weekly. If you want to support my work and get really cool perks like behind the scenes and early access, please visit my Patreon in the link in the description below, or sign up as a YouTube member. Come and join the crew. As always, stay safe, stay happy, and I'll see you again next time.